Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. Alhamdulillah, we managed to continue for our previous session on our video tutorials on what we call this thing, left gear connector. Before, I've told you about how we can import another part from SolidWorks to do some another kind of geometry by using combine in SolidWorks. We import another part and we attach the part. In this case, is a external gear, which a middle gear connector that I've shown you in the previous tutorial. So the gear, the external gear, that will be import into this file, into this viewport. So then we attach it by using move body command or by using mate. After the gear is put into the right position, then we can use combine in SolidWorks, combine, then we can do subtract. So these two structures will become internal gear. So let me show you the step. The first thing is I import by using import part model in gear cutter, which is a modified gear cutter. If you look, this modified gear cutter is actually from the medial gear connector. That I do some split, then we have certain portion of it. So then what I did is then I move part by part, because the external gear here, they have two parts. One is the outer ring and then the inner ring, outer gear, inner gear. So the outer gear will be moved directly in position. Then after the, if I zoom, let me zoom it a little bit. After the bigger gear here, the bigger gear here have been put into the right position. So I do combine in SolidWorks, where combine we can do subtract. So now we have the internal, what we call this, the inner gear. Okay, same goes for this smaller gear here. I use body, move, put it into the right position, then we use combine, then we have the component is subtracted to become internal gear. So we have both internal gear. So the idea of using this import another body, another part into this file, and we do combine subtract, so we can get the internal gear. So we don't have to reconstruct reconstruct again the internal gear, like I've shown in the middle gear connector. So let me show you an example for this case. Let's say if I open a new file, the top plane, I do circle, then I do another circle, so then I put a dimension here, and here is 14. Then I do some offset, this to this one. Make sure it's reversed, and also the circle. Click OK. the contours, this part, this contours and this contours. So then we have so this an example to represent how I import the gear cut, another part from SolidWorks, so to be cut to these two portion, to these two component tools. It will come a gear teeth. So how do we do that? So insert, we go to insert. So first thing we got to insert the part. So the part that I'm going to insert is a gear connector modified. Let me check. Gear cutter modified, right? Gear cutter modified. So the first thing what we should do is, so this gear cutter modified, so I put it in certain position, right? So when it firstly at the beginning, so we have some settings here to do some orientation of these two gear cutter. So what we should do is under made setting, so I select this bottom surface and this top surface of this component. So what I should do, I put it, because I need to rotate these two parts, so the gear cutter is in the right orientation, so it should be 180 degrees. Okay, then I use some add buttons. So or you can click OK first, so the position is locked. I mean the orientation of this gear cutter is in the right orientation. So the next step is use under insert, so we have features, so use move body. The idea of to use this move is to put, to make I do it part by part, this internal gear to this part, so then it could be subtracted here. So the body to move, I select the inner, not the main, the bigger one, the smaller one. So the made setting. So what I should do is I select under made setting, I select the top surface. Okay, the top surface and the top surface of this inner cylinder. So okay, the first thing, it should be coincident, because coincident, if you look through, it should be in the right, on the same height. So I click add. So another step is, the next step is select this surface and this surface. So let me clear this thing again. Clear that. Select this surface and this surface. Or I can select these inner edges and these inner edges and make it SolidWorks will automatically put it into concentric, so the internal gear is in the right position. Okay, let us zoom in this part. Okay, then we use another the next step is insert features. So we use combine. The main body is not the bigger cylinder, the smaller cylinder here is our main body. Then bodies to combine is the gear cutter that we attach to this part. Make sure you carefully selected this component, gear cutter modified. Then make sure that the operation type is subtract when you click OK. So the internal part is subtracted to form a gear teeth. So you do the same procedure on the bigger gear here. First you use insert, features, move body to move this component, gear cutter, modified gear cutter. So under mate setting, so you can either select the inner edges and the inner edges of this cylinder. So it is the first step is position into concentric, then you click add to lock it. Okay, to lock it. So another mate setting is you select these edges and these inner edges, or let me clear again, clear selection. You can select this face and this face to be coincident, so the external gear is in the right position. Click OK. Then we use insert, features, combine. The main body is the bigger cylinder, and the bodies to combine. Carefully selected the gear cutter. Then you click OK. So we have the internal gear. Okay. At least it will guide you how we do this internal gear, internal teeth, internal gear. So that's how so let me show you the. So let me quit this one. Alright. Okay. So we already have our internal gear. Then I do some cut extrude. Cut extrude is actually where is it? Let me recall which cut extrude. If I select, yeah, this portion. Okay, this portion, before we cut extrude, this part is solid, so I do some cut extrude, because we have, when we combine the left gear connector and the right gear connector, so it become a hole. So the cut extrude actually is from this cache. Since we know the dimension is the dimension of the hole is 11. Okay, and exit the sketch. So we cut through. Then I make a plane. Okay, the plane here is for me to do the internal part, since in this hollow cylinder there will be some structure there. So after I do this plane, then I do rib. Yes, let me recall. Yeah, actually the plane is for me to do the rib, it's not the internal. Okay, the rib is in the right, so our rib will be our sketch. When we have rib, we do some sketch. This line, so then we do rib. Okay, then after we have this rib, the rib must be in the right plane. Okay, so the plane, so when you do rib, make sure that the material of the rib will be lower, so that the material will be facing downwards. so that you can form the rib. Okay, after rib, then let's go to the next step. I do some cut extrude. Cut extrude, when I highlight the cut, where is cut extrude? Yeah, hold on, the bottom part. Okay, cut extrude at the sketch. Zoom to fit. Right, let me zoom in a little bit. Okay, okay, this is about actually this is the top part, not the bottom part. At the top part, so make sure that you cut extrude on the right plane. Since the surface here, you do the circular sketch, circle here on the right plane. So if I have a circle diameter 10 there. Okay, on plane 1. Okay, plane 1 is actually okay, then I do some cut extrude. The setting of this cut extrude is blind, and the depth is about 5. Then another cut extrude to form the hexagon ball, where the plane is the sketch plane is on. The sketch plane is on the surface. Okay, so we have cut extrude hexagon here. Sorry that my computer is quite slow since I'm using my old laptop, so it takes some memory, is a lot of memory consumption, and also CPU. Okay, then okay, and then the next one is a boss extrude. Okay, the boss extrude is there will be some additional feature. If you look, okay, this is before and this is after. If you look, if you look through this sketch, if I did this sketch, so we have, okay, we have 2 circles here. Then 2 circles here. Then select the contour and to form the smaller radius for the ball. Smaller radius for this hole to make smaller. This might be not actually the best approach. So this is how I do things. Maybe you can do it better. Then I do some revolve. Where is revolve? Yes. Yeah, the top part of it, revolve. Since we have some slightly a dome shape here, so a dome shape there, I use revolve on this, on the right plane. If I look on the sketch plane, okay, on the sketch plane, actually the sketch plane is parallel to the front plane, or if I'm not mistaken, it's a front plane or maybe the right plane. Okay, so you do some sketching. Okay, if I edit the sketch, so I have some sketching here. Okay, so that it will be revolved to form like a dome shape here. Okay, let me exit the sketch. Okay, then the next step is doing rib. This rib, okay, we have a rib. So the rib, the plane is I think it should be parallel on this for how I do this revolve of this dome shape. So this should be on the same plane, or you create another new plane there. So the rib parallel to the front plane. So if I yeah, okay, so we have our rib here. Sorry, let me exit this cache. Okay, let me edit this cache. So this is our rib. Okay, let me go to normal view. Let me look through to make sure you're on the right plane, and make sure that you draw a spline here. Spline. Okay, then after you do a spline, then we do a rib. So the rib parameter should be 0.25mm thickness, because it's really tiny. Then make sure the direction is toward the bottom. Okay, then you have rib. After rib, then we do circular pattern. Okay, circular pattern. Make sure that circular pattern is on the right plane. Okay, you have circular pattern. Okay, if I edit the feature, so the feature to pattern is a rib, and then the direction of a circular pattern. So I select these edges. Okay, these edges. So the number of rib is 15. So we have this circular pattern rib. Okay, the next part is I use rib 5. Where is rib 5? Rib 5 is, yeah, it's at the bottom. Okay, rib at the bottom. Make sure it's on the right plane. If you look on the sketch of this rib, it's a single line. Same procedure to make sure that your rib must be facing of the rib must be downward. So then we use the circular pattern, or we call it circular array. If I edit the feature, we have number is 4. The edges H1, I use this top part of this cylinder component edges, and the component features to rib is the rib. So we have 4, so it will form the 4 ribs. Okay, what's next? I think it's the last one. Finally, thank God. Okay, what is it? The internal gear here. So for internal gear, I use I didn't use the previous. I've shown you previously how I import the external gear to cut here, but for this internal gear, this a portion of internal gear. When you combine both casing here, the left gear connector and right gear connector, it will form a actually it will be attached to a what we call it, if I show you on my images, let me check. Yes, the component, where is it? Oh, this one. whole component. Yeah, what we call this kind of gear. This component will be fitted into the soles, since the component here, this kind of external gear here, it have a V-shaped teeth, so it will be inserted at this point, so it will when we clamp together both of these casings, so it will attach to form and assemble, so it will kind of gear will be a driven gear. So this the internal gear will be driven, so it will be nicely fit into this casing through these holes. Okay, I hope this video will at least guide you so how I do things for this part. So I will not show you. This is a left gear connector. For the right gear connector is actually the same. The only different for the right gear connector is they have a different kind of bore here. There's a direct circle extrusion here, and I think that's all for this component. Okay, thank you very much for listening. Wassalamualaikum warahmatullahi ta'ala wabarakatuh.